Welcome to Chapter 2. For this starter, I want you to pause the video and go through and fill in all of these trig functions for this triangle, and then you can unpause it and make sure that you got it right. So always remember, little a is a side length across from big B, and so on. So sine of A is going to be A over C, cosine of A is B over C, tangent of A is A over B. Now we take the reciprocal of those to find the remaining ones in blue. So cosecant is going to be C over A, secant is C over B, and cotangent is B over A. Now I should have done these in other colors, but oh well. Sine B is going to be little b over C, cosine B is little a over C, tangent of B is B over A. Again, now we just take the reciprocal to get C over B, C over A, and A over B. Okay, today we're going to be talking about right triangle trig. A lot of this is going to be review from geometry with some new things sprinkled in a little bit. So if we want to find the 6 trig functions of a triangle, okay, we can find all of these. First we have to figure out what little b is. Okay, you can use your Pythagorean theorem. If you've got two sides given to you, you can find the third, a squared plus b squared equals c squared, or if you remember your Pythagorean triples, you know that b has to be 8. This is just a double of a 3, 4, 5. So 6 is twice 3, 8 is twice 4, 10 is twice 5. Okay, so I've got those 3 side lengths. Now I can go and find 6 trig functions from A. So I'll start with these 3 right away. Sine A opposite over hypotenuse is 6 over 10. We need to simplify. We're always going to be simplifying these fractions. So sine A is going to equal 3 over 5. Okay, cosine of A, that's 8 over 10, which simplifies to 4 over 5. And tangent, well, that's going to be 6 over 8, which is 3 over 4. For the remaining 3, I'm going to just take my answer from those 3 and flip them over. So cosecant of A is the reciprocal of sine, so that's going to be 5/3. The secant of A is the reciprocal of cosine, so that's 5 over 4. And cotangent is the reciprocal of tangent, so cotangent of A is 4/3. All right. So this is the new part. Since A, B, and C all add up to 180, the angles of a triangle add up to 180, and we know C is a right angle in a right triangle. The other 2 angles are complementary. That's not new. What is new is these things called cofunctions. Okay? If you take the sine of A, that's the same thing as cosine of B. Or if you take the cosine of A, it's the sine of B, etc. Okay? These things are going to be very, very handy in various problems. Okay, so if you just know what that is, it makes your life a little bit easier. Okay, in trig, we say the trig function of angle equals the cofunction of its complement, so it's called the cofunction identity. So filling these in, sine and cosine, those are your cofunctions. Okay, now of the complement, so what adds with 30 to get 90? That is 60. Okay, what adds with y to get 90? Well, 90 minus y. What adds with 75? That's 15. Okay, so filling those in, going back and double checking, it's not a bad idea. Secant matches up with cosecant, and then what makes the complement? Cotangent, tangent match up, sine and cosine match up. All right. Now this monstrosity is hugely important. Makes your life so much easier in trig and in calculus going forward. If anything, you need to memorize just this quadrant. If you can memorize that quadrant, you can get the rest. Okay, because the rest are all just transformations, mirrors of this thing. One thing that's helpful to remember is that the ordered pair is cosine of theta, comma, sine of theta. What I mean by that is if I look at cosine of 30 degrees, 30-degree angles right there. This is cosine of 30 degrees. That is sine of 30 degrees. The way that I personally remember this Cosine comes first alphabetically, just like x comes first alphabetically in an x-y ordered pair. So cosine comes before sine. That helps me remember each of these values as well. Okay, the numerator, as I'm going from left to right, I'm getting further away from 0. My x is getting bigger. So I go 1/2 square root of 2 over 2 square root of 3 over 2. I just remember everything is over 2, and I remember everything is a square root on top. And I go 1, 2, 3. Square root of 1 is just 1, so you can get rid of the square root, and then you've got the rest. Then sine is the reverse, okay? Because as you go up, you're going to go up 1, 2, 3 this way, okay? Because your angle is getting higher. As your angle gets lower, that y value is lower, which makes sense as to why that fraction is smaller, okay? That's just how I remember it. If you've got another better way for you, use that, okay? And then I've talked previously about how in the first quadrant, everything's positive. Second quadrant, you've got a negative cosine, positive sine. Everything's negative, excluding tangent, I suppose. And then positive cosine, negative sine down there. Okay, so that's going to be very, very important for a lot of these problems. So these are things that you should just know. So sine of 30 is 1/2. I probably should have spaced these out a little bit more, but oh well. Cosine of 30 is square root of 3 over 2. And then tangent, I always remember, is just sine over cosine, so that's 1/2 over square root of 3 over 2, which if I simplify that, I get 1 over square root of 3. Okay, if I want to rationalize, that's square root of 3 over 3. The sine of 60, that's my square root of 3 over 2. Cosine of 60 is 1/2, and then tangent of 60 is going to be the square root of 3. Okay, it's the reciprocal of 1 over square root of 3, which is just square root of 3. I could take the reciprocal of this, and then I'd rationalize again since I rationalized the first time, and that's just a lot of extra work. Sine of 45 and cosine of 45 are identical. They're both square root of 2 over 2. And because of that, tangent of 45, which is my favorite trig function of all time, it's just 1. So using the exact values, those are the things we just used, those fractions. We want to show that these things are true. So this number 1 says cosine squared of 30 degrees plus sine squared of 30 degrees equals 1. So cosine squared of 30 degrees. I don't know why I'm writing that a second time. What is cosine of 30 degrees? And then squared. Well, cosine of 30 degrees, that's going to be our square root of 3 over 2 plus sine of 30 degrees is 1/2. So when I square those, I get square root of 3 is no longer square root of 3, that's just 3. 2 squared is 4. 1/2 squared is 1/4, which is 4 over 4, which equals 1. So I know that that is true. For the second one, cosine of 45 degrees is square root of 2 over 2. I'm going to square that. It's the exact same thing with sine of 45 degrees. So that gives me 2 over 4 plus 2 over 4, which is 4 over 4, which equals 1, which is what it's supposed to equal. All right. Next, we want to simplify these while we're given a specific variable measurement. So this is 2 times sine x. So think of kind of an order of operations thing. Figure out what sine is, and then do 2 times that. So 2 times sine of 30. That's 2 times, well, sine of 30 is 1/2. 2 times 1/2 equals 1. Now this time it's sine of 2 times y, so that's sine of 2 times 45 inside these parentheses. Sometimes you'll see me write this with parentheses, sometimes not. I kind of go back and forth, it depends on the problem. But this is sine of 90. Okay, if the 2 is out in front, I take 2 times whatever sine of that inside piece equals. If the 2 is inside, I have to multiply the inside before I take the trig function. So sine of 90 is 1. Okay, that's straight up 90 degrees straight up from the origin. So this one is a combination. So I've got 4 times sine of 3 times 30 minus 90. Inside those parentheses, the order of operations still applies. So 3 times 30 is 90. I've got 4 times sine of 0. Sine of 0 is 0, so 4 times 0 is 0. All right, so I went through those pretty quick. there's the homework assignment. Remember, try a few of these. We will work on some in class as well. Please bring questions. That makes my job a little bit more enjoyable, and it makes it so most of us have a better understanding. Even if you're like, I kind of know what I'm doing, ask a question, because someone else might be too nervous to ask that same question, and maybe you can ask it for the entire class. All right. Hope everybody has a great day.